second bolt. So 2 bolts are in the circuit. And switch it on, make sure it works. And then repeat these readings. Repeat these readings. The 3 readings.
Ini in parallel kan? Selari kan? Selari. Jadi kan? Kalau sambung siri. Selari sama-sama rotation.
In parallel. Can you put your bolts in parallel? Parallel.
Oh, parallel. Ni tuan. Siri. Parallel sama satu, sama kanan, satu lagi sama kanan.
Oh, they are in parallel. You got it. And you got different. Yeah. Bolts in parallel.
Selari. 3 volt boleh 12 volt sama.
Two bolts in. Why is that? Have you which resistance have you increased? Both. No, it's not. In effect,
Yeah, same.
wiring and the switch. Someone was saying to me,
It was outside. Normally, and there doesn't seem to be much wind, but there was a little wind, so it does make a difference, you know. So good example. Pardon? We can try another one later. Yeah, of course we can. We just need some more toilet rolls. I better not take any more out of there, otherwise people will be saying, "Where's the toilet paper?" It's all burned away, hasn't it? The tube. Unbelievable. That's good. They knew that. Yeah. Scary. Right. Yeah.
Ada view lagi tak? Ada buat? Ada. 5 minutes.
Guys, bagi wire je. Okay, we will cari system views. Yeah.
If you put your meter now to resistance, you have to change the connection again. Change the connection on your come back to your
Check to resist.
put it to ohms, 200 ohms. 200. Can you all switch your meter to ohms? Put it to 200.
Betul lah 200.
Coba deh bawa wire kosong ni. Satu lah, error.
Move your plug on the meter back to the volts, ohms, and volts, milliamps, and ohms. Move that. Plug it. In the UK, it's spring. and we use this cable. This cable that you saw, the biggest of these cables, single conductor, but that is 2.5. One thick wire, 2.5. Here you have 7 strands. Yeah, 7 strands, but makes up 2.5. That's the size. Okay, thank you. Let's get the other end. And put it in there. You see, we've got 7 strands here. Is it 7? 3. 7 strands. Yeah. And that makes the same size cross-sectional area as our big one. We say that our cable must have no more than 27 amps. Okay. What I'm going to do is I'm going to put 3 times that through this cable, and we're going to see what happens. We'll put 27 amps through it first of all. What we've got here is a simple rig that the gentleman here have made for us. And what we can do here is, this is a transformer. Well, I wanted a fairly long bit. No, leave it like that. That's it. We've got this rig. We'll come back to this rig and talk about it later. But what I'm going to do is just pop that over the edge so that it's not burning anything. If our socket works, yeah. Clamp ammeter. This is what we call a clamp ammeter. It's off, isn't it? Yeah. And if we set this to amps and we actually clamp this around a piece of cable, we could probably clamp it around there. We clamp it around just one conductor in a circuit, we can read the current flow. But it has to be around one conductor. If you put it around a cable like that, because you've got the current flowing that way and there's the same coming back here, it cancels the reading. Okay? So it's got to be just around one conductor. We can measure the current flow. So I'm afraid you won't all be able to see this, I don't think. If we put that there, is that okay? Sorry, is that okay? Yeah, it says 2.7. Is it 0? Is it 0? It's reading 2.7. That one. 2.2. Let me change the range or something. What I'm going to do then is that I've got this clamp ammeter around there measuring the current flow, and I'm going to turn this up and put a lot of current through this. I'm going to try and bring it up to 27 amps. I think that it'll work easily, won't it? So turn it up till we get it 27. Sorry? In the UK we'd say that you can take 27. There we are, 27 amps. If you'd like to feel that, you can probably feel that it's going to get slightly warmer. Voltage is very little. We can actually put the voltage across there. It'd be very little. In fact, it's not reading.
Not reading.
No, 0.1 it says. But I think you've probably only got a volt open circuit here, haven't you? I mean, if we just switch it off a minute and just disconnect one of these, just to show him. Just disconnect one end.
Low.
What? No. Got very. We've just got no reading basically. It's a very low voltage. It might be too low for this meter, but it is working. It was working, wasn't it? Yeah. Yeah. So in effect, we've got very low voltage, less than a volt, and in fact we can't measure it on here, across this cable. But there's very high current comes out. The way we've got the transformer wire. Can you just put it back in? Thanks. Okay, we'll set the experiment going. I'm going to put 27 amps through, as I said. The lowest range I've got on AC is 200. This is only about 1 volt. Less than. Much lower. Go to 54. Right, 54. It'll take a while for the heat to build up.
Sikit lah, sikit kak. Lebih sikit. Lebih sikit. Ada.
Dapat edit tikus tu, tikus.
Oh, tu lah sikit lebih. Oh, sini panas.
Tikus.
Because it is getting hot now, is it? Yeah, starting to get hot. And because it's getting hot, what will happen to its resistance? Its resistance will increase, and that's why, if you look, the current from this combination is going down, because the resistance of the wire is increasing. So if we look at that meter, it's going down all the time. I've got to keep it at 54. I've got to turn it up. Okay, I've got to keep on turning it up. What sort of temperature would you say that is? Hot. No, I can touch that. It's below 50. It's just getting close to 50. Yeah, starting to. It's getting close to 50 now. Getting close to 50. Near 50. Yeah. Okay. And we're at twice the rating of that cable. Okay. Twice. You would think. Perhaps you would think. Not that.
Yeah, I think it's more than 50. More than 40.
Yeah, it's 50-ish, approaching 50. So that's not dangerous, really. Not dangerous in terms of the cable. What the IEE say is that the maximum temperature a cable should go to when it's in operation is 70 degrees centigrade. A cable of this. Shall we go to 3 times? Has anybody got a watch or a stop clock that they can record?
When this thing is happening?
Yeah. Anybody got a watch? Well, you can use mine.
Stopwatch.
I mean, this is hot to start with, okay? But yeah, all right. So if I turn it up to, I'm going to 3 times now. What's 3 times 27?
81.
81. Let's go to 81. I'll tell you what. Well, you start it from now, John, because the cable is small. 81. It's very rapidly going down. The current flow is going down again because the cable's getting hotter, resistance increasing. We'll have to turn it up again.
Sudah bau?
30 seconds.
Right.
Alright. Ada asap lah. Ada asap. Pyrolysis.
Starting to what?
Pyrolysis.
Work. Can you see?
There's some smoke.
Smoke. Smoke now. Okay.
Oh, so the context there.
At the contacts, so it might not be very good.
Oh, what's up?
1 minute.
1 minute, right? Oh, it's smoking, right? That's the maximum. Now we're at the maximum of this, maximum capacity of this transformer.
3 times.
Six amps. Oh,
1 minute 30.
so you mustn't go above that. But it's, so I should turn this down. Do we want to see what current we've got into there? Oh, we're all right. Oh, 7.
You can egg, maximum egg.
Maximum out of here.
2 minutes.
So we're on. But we're on.
0? Yeah. 125 can 68.
Yeah, but we're not.
Jangan lebih, jangan lebih.
Jangan lebih.
Don't over the limit.
Yeah, but we're not getting much. We're not putting much current into here. Is that you mind?
2 minutes 30.
It's not overloading this. Yeah, I think because we just not.
Let's get this one over. Let's get this one.
But it will burn. But we've not got more. We've got very little.
Kamu tengok dah ada awal dia.
We haven't got any at the moment.
Dah mat lah ni.
Oh, we still got. It's still working.
Mesti okey lagi tadi. Tak apa pegang-pegang. Kalau ni boleh menang je. Orang ni cabaran. Tak ada tangan tu.
3 minutes.
But we're up.
Yang ni juga.
I'm sorry, we can't actually put 3 times. We can't maintain this 81 amps. It's dropped down to 71 now. But you can see that the cable's starting to cook. But how many minutes, John?
3 coming up to 3 1/4.
Okay. What we could do then, you were probably right at the start. Put your shorter piece in.
3 1/2.
We'll get. Yeah, I've just stopped it, John. We'll just drop this piece of cable out, and we'll do another. We'll do a shorter piece like the gentleman had to start with, because the shorter. You ready, John? Straight to 81 amps. 81 amps.
You started it?
Yeah. We're at 81 now. Keep on turning it up.
Insulator kita lama mana? Temperature berapa? Tahan.
Ni.
30 seconds.
100 kot.
81. IE
So that's three times the rating of the cable. Or in according to the British.
Kalau waktu kita beli cable tu kat sana ada spek.
Ni,
1 minute.
berapa temperature dia kena tahan. Dia melting point. Insulator. Kau buat ada 3, yang nombor 1 dia macam sama. Dia bagi kita
How many minutes, John?
120.
Malam
1.5 minutes.
di bawah 6 lah. Dia 85.
Shall I go a bit higher? Are you happy? You know, it's not happening very quickly, is it? Shall I try going up to 90? We go up to 90 amps. 90 amps. That's 92-ish. Right, 90 amps now, and it's starting to
2 minutes.
89, 90. Now, once it starts smoking like that, those pyrolysis products, that is basically the you know, in the insulation there is plasticizer in the insulation. It's PVC, which is a hard plastic, which has got some softener in. It's got phthalate esters in there to soften it.
2.5 minutes.
If we had a match, somebody could. Wouldn't somebody just put a match to that?
Very
Right.
toxic product.
Lebih kulit ni ya.
Gentlemen, just remember that. Don't
Yeah,
breathe them in.
don't breathe
Very
these in.
toxic. Very toxic.
What are we doing it outside?
Kalau paper jatuh, after jatuh tu paper.
So it will burn,
3 minutes.
but okay, it's taken that. Switch it off now. So it's taken don't burn. This is that although first of all when it starts to cook, it's mainly the plasticizer that's coming off. Later on, when the PVC is getting damaged, then you get chlorinated stuff coming off like phosgene and the stuff that's highly carcinogenic. So that's why John says don't breathe it. But you can see
Some of them are not.
well there shouldn't be nitrogen in there. But they are carcinogenic, so don't breathe them. Right. Okay, so can you see from this demonstration that you've got to really overload a cable before it can cook to the state at which it would short circuit? Thinking that there'll be two cables there in a run like this, they both be carrying the same amount of current. It's got to get to this sort of damage before it can short circuit. Okay? But thereafter it could short. But we're looking at least 3 times the rated value before serious damage is done. What we've got is a supply from the mains, okay, from the main supply would come into the house, and we've got the live and the new volts AC. I've also got volts DC. Volts DC ranges if the circuit is energized. And obviously find the live, and that says live, and earth, and we get 238 there, live and neutral, 236, okay. That cable should be fused at around 30 amps. It's got to be fused at well, put it this way. It should be fused actually a bit lower than the rating of the cable. Okay? So it ought to be fused at, say, and you saw how long it took for the cable to cook, for the cable to get really hot. You saw how long it took? About 3 minutes at least, was it? Right, what we're going to do now is just to look at how long it takes a 32 amp breaker. If this will work, we might have to use there's a 16 somewhere. We might have to try it with a 16. Depends on how powerful this combination is. But, is it all on? Something wrong here. Start again. AC and DC. AC. Right. I'm going to put 32 amps through it if I can. I've got 32, roughly. 32 amps. 33 it's got to. Messing about a bit, but 26. Turn it up a bit.
Not stabilizing.
No, it's got an internal resistance which is fighting us, in fact. We close, there is a little bimetallic strip that's